Friday, I introduced this term called the centroid, which breaks any median up into a ratio of 2 to 1. Always 2 to 1. The ratio is never different. It's 2 to 1. Today and tomorrow, this is going to be a 2-day topic. Today and tomorrow, can I break a segment up into different ratios now? Right, different ratios other than 2 to 1. This process, just so you know, because you're going to see the word come up more and more, this process is called partitioning. All right, I don't know if you've heard of that word before. All right, just in general, other than it's not, I'm sure you haven't heard it in math, but just in general, partitions. Honestly, I think of the library. I don't know if anybody ever sits in like the little study cubicles or breaks it up. Those are partitions. All right, it breaks something up into smaller areas. Maybe too, you've heard of office cubicles, right? Office cubicles, that's what partitions are. They break something up into smaller pieces. So that's what we're going to do with a line segment today, is break it up into smaller pieces. So my first line segment up here, I have line segment AB. I want to try to break it up, find a point on there, find a point on AB that breaks it up into 2 to 3. Here's what I mean by 2 to 3. When I look to the left of the point you find, it's going to be 2 congruent segments. And when I look to the right of the point you find, it's going to be 3 congruent segments. So 2 congruent to the left, 3 congruent to the right. So before we start to find this point, anybody have an idea? What would it make sense to break this up into how many equal segments before I find that point that does that? 2 to the left, 3 to the right. I might want to start breaking up line segment AB into how many equal pieces? 2 to the left, 3 to the right. Into 5 equal pieces. So that's what I want you to do. I want you to put points on here. And again, I'm not looking for greatness here at all. All right, eyeball it. Don't take a ruler and divide it by 5. Put points on here so it looks like I have 5 equal line segments right now. So everyone's got something that looks like you have 5 equal line segments. Now, you had point A and point B. You just added 4 points on your own. Now you have 6 points up there, right? You have 6. Can you draw an arrow to the one that would break it up into 2 to 3? Which one of these 6 points that you have up here would break this line segment up into 2 congruent to the left, 3 congruent to the right? Which out of these 6 points would do that? Because only one does the trick. And hopefully all of you are pointing to this one right here. Again, 2 to the left, 1, 2, 3 to the right. All right, let's keep going. 1 to 3 now on the next one. 1 to 3. Can you find a point that would break it up into 1 to 3? Again, how many equal parts would it make sense to break it up to first? 4 equal parts, right? So go ahead, do your best. Nothing great. Do your best. Break AB up into 4 equal parts now. 4 equal line segments. AB. Break it up into 4 now. If I'm going to go 1 to 3. So you have 5 up there now, including A and B. You have 5 points on this line segment. Point to which one now. Draw an arrow to which one breaks it up into 1 to 3. 1 to 3. And hopefully you picked that first point there after A. I'm surprised nobody's asked this yet. Why can't I just pick this point right here instead, right? 1 to 3. I'm always going from A to B. Why can't I ever go from B to A? And here's your second part of the directions. I introduced the word partition. Also in your directions will be this term, directed line segment. All right. And we're going directed line segment AB, which tells me you start at A and go to B. Direct it from A to B. If I want to go the other way, I'd go directed line segment BA instead, if I want to go the other way. All right, so you'll see that in the directions as we start these problems here in a second. A to B, directed line segment. All right, let's keep doing a couple more before we get into actual numbers. 2 to 1. All right, break this up into how many equal spots? 3, right? Go ahead, break it up into 3. Your best ability. And then draw an arrow to the one you think it breaks it up into 2 to 1 now. 2 to 1. Two to the left, 1 to the right. If this was a median, that would be called the centroid. All right, 2 to 1. And yeah, I'm going to be that guy. 3 to 5 for the next one. 3 to 5. How many equal parts? 8 equal parts. Whew, go ahead. Break that bad boy up into 8 equal parts. And again, draw an arrow where you think breaks it up into 3 to 5. No issues so far? All right, and this last one here, I'll throw at you, see if anybody's on top of their game. 1 to 1. Break it up into a ratio of 1 to 1. So how many equal parts? 2, right? I could have asked you just to find the what, though. There you go. This is the same as midpoint, right? 1 to 1 is the same as find the midpoint. All right, I'm not going to do this all day. All right, I just wanted to get you the idea of the ratio, how it's split up. We're actually going to go on a graph, and you're actually going to find the point that does the trick. All right, so do your thing. There's line segment AB, graph it for me, and then we'll talk. Don't make any markings other than AB. Just draw on line segment AB. And draw in the actual segment, please. Just don't mark A and B. Draw in the segment. Few things before we get going. Notice it does say directed line segment AB, so that tells you go from A to B and not B to A. And there's that word partitions. Find the point that partitions it into 2 to 3. All right, first question for you. As I go to the numbers here. Please don't make any, I'll mess up my diagram, don't mess up yours. Let me do it all on mine here. How many equal parts do you want me to break it up into if I'm trying to go 2 to 3? 8, Char, how many equal parts? 5. Okay, so here, ready? I'll break mine up into 5. Don't touch yours. Let's see. 1, 2, 3, 4. Okay, there's 5 equal parts. I'm looking for the one that breaks it up into 2 to 3. So I'm looking for what that point is. But unlike the little cute diagrams we did on the first page, I want to actually know what the heck that coordinate is. And I have no idea if I actually broke it up into 5 equal parts, so I just can't go by my cute art. I need to actually do this algebraically now, adding, subtracting some numbers together. So over to the side here, here's how we're going to do it. We're going to do this twice. Once to find the x coordinate, and then a second time to find the y coordinate. So here's how we do it algebraically. First step is, Shara said, hey, you got to break this up into 5 equal parts. Okay, break what up into 5 equal parts? Well, we're going to break the distance between the x coordinates up into 5 equal parts. So I'm going from -3 to 2. First thing I need you to think about, what's that distance there from -3 to 2 on the x-axis? John Carlino. Hi. I do, yes. Yep. Okay, yeah. Okay, you got it. Thank you. Yeah, bye-bye. Okay, so going back to you guys, what is the distance between the x coordinates up here? -3 and 2. That's a distance of 11, Makai? 5, right? So I'm taking that distance of 5, and you guys just told me you got to break this up into 5 equal parts. So every time I break it up, it's going to be 1 unit. Take a look at my graph again. So that means every time I want to break it up, I got to go over 1 unit, over 1 unit, over 1 unit, over 1 unit, etc. All right, every time I get one of those blue points on my line segment, it's 1 unit over. All right, well, how many times do I need to go 1 unit then to get to that 2 to 3 point? Do I just go once and I'm done? Do I go twice, 3 times, 4 times? What's the deal? How many times over do I need to go to get to that point? How many times do I need to move? Once, twice to get there, right? So I need to go 1 unit 2 times. Where else could I have gotten that 2 from? The ratio. The first number in the ratio tells you how many times to go over. All right? So in total, we need to go 2 total units. That's not where I end up. That's not my x coordinate. That's how many units you need to move from the start. And speaking of the start, what x coordinate did I start at? X coordinate. What x coordinate did I start at? Jonathan? I started at -3, and I have to go over 2 total units. So where do I actually end up on the x-axis? If I start at -3, go over 2 units total. Jonathan, back to you. Where do I end up? So there is the x coordinate I end up at -1. So I cut the distance by 5, and I say, oh, I need to make 2 moves. So that's why I multiplied that distance by 2 and not 3. All right, here we go. Now let's do the same exact thing, but to find the y coordinate. So look at your y coordinates from A and B. Determine the distance now. From this to this, what's my distance on the y-axis? All right, how far apart are they? Alyssa, how far apart are they? What are your y coordinates first?
-4 and 0.
Okay, how far apart are they now? From -4 to 0, how many units do you go?
4.
4 units. Still dividing that into 5 equal parts. Hey, the numbers aren't going to be pretty sometimes. Welcome to above average math. It's not going to be nice whole numbers every time. So now that tells me 4 divided by 5. Yep, we're going to our calculators. Break it up every time by going 0.8 units. 0.8 units. Again, ready? Again. How many? Do I just go 0.8 and I'm done? Do I have to go another 0.8 or for a third or a fourth time? You tell me. Up 0.8. Up 0.8. How many times do I have to go 0.8 to get here? Still what? Twice. This number, that first number in the ratio will always tell you how many times you need to do it. Do not look at the second number. The second number, like the 3 here, would be if I'm going from B to A. Okay? I always go by the first number in the ratio. So how many times am I going 0.8? Twice again. I always go by that first number in the ratio. The second number is only if I'm going from B to A. So how many total units am I going to go then? 0.8 times 2. Shara? I'm going 1.6 total units from the start. From the start. And speaking of the start, Where did I start on the y-axis again? 2, 6. Alyssa, where did I start again? On the y-axis, where did I start?
-4.
So from -4, I go up 1.6. And where do I land on the y-axis now? Two zip. Brendan, where do I end up?
-1, 1.6.
So I end up at -1.6 on the y. -1.6?
No, I said 1.6.
-4 plus 1.6, right?
-2.4.
-2.4. Now, this is our first time doing this. I think that's the answer. I think I did all my math right. This is why you graph every single partition problem. It's not optional with me. It is not optional. You are graphing every single partition question, and here's why. At the end, you are going to check if your point actually lands on your line segment or not, because if it doesn't, you did something wrong. So I go, take a look, I go over -1, down 1, 2, and a little more. Oh, look at that. It lands right on my line segment. Hey, you get something way up here, you did something wrong. If your point does not fall on the line segment, something went wrong in your calculation. And also, take a look where it landed. 2 to 3. So the part to the left should be a little smaller than the part to the right. 2 to 3. That's something else you want to check to make sure not only did it land on the line segment, but in the correct position. All right, one doesn't make you great. We're going to do one more together, and then I'll let you do one on your own. Okay, first step. How many equal parts should I break line segment AB up into here? How many equal parts is this going to be broken up into based on the ratio? Jonathan, what is my ratio?
-2,
My ratio.
4:1.
4 to 1. So that tells me to break it up into how many equal parts? 5 equal parts. All right, first thing I'm going to divide up into 5 equal parts is the distance between the x coordinates. Distance between the x's, which is -2 to 2. What's that distance between them? 1, 8. Lily, what's that distance? 4. So I'm taking 4. Good. Dividing it by 5. Again, sometimes these numbers aren't going to be nice whole numbers. 0.8. Next step, figure out how many times you need to move 0.8. Go back to the ratio now. How many times do you move 0.8? So 0.8 times, how many moves do you have to make of 0.8? Look at the ratio. You got to move over how many times? 9, Vinny? 4 times. Yep, that first number in the ratio will tell you how many times you got to move. So I'm going 0.8 4 times. For a total of 2, 1, Lauren? 3.2. That is not what my x coordinate is. That's not my x coordinate. That is how many units you need to go from the start. And where did we start on the x-axis? Where did we start? 12, Finley? So from -2, you go over 3.2. And that is where I end up on the x-axis. All right, where do I end up on the x-axis then? Ones. Micaiah, where do I end up? Good job, 1.2. So So it's going to be 1.2 comma, here we go with the y's. Please lock in when we do the y coordinate together. There is a little bit, something happens here that has not happened yet. I want to make sure you're ready for it. All right, we're still dividing whatever the distance is by a 5, right? All right, what is that distance from the y-axis? Between your y coordinates, what's that distance here? Vinny?
Negative 8.
Okay, whoa, all right. You jumped the gun on me. It is 8. Why'd he throw a negative in there? Where's that? What's that? What that negative telling us? Look where we're going. 8 units down, right? So I'm going to put a negative there. That doesn't mean the distance is negative. That's just telling us we went down 8. And watch why we need that. At the very end, I'll come back to that and be like, this is why we needed that negative there. All right, so we went down 8. So that's why I'm putting a negative there. So every time you break it up, you're going to go down, what's that, 1.6? I'm going to go down 1.6. All right, how many times do I need to move down 1.6? Look at your ratio, or look at what we did for the x too. How many times do I have to go down 1.6? 1.4, Stephanie, how many times? I go down 1.6. I'm still not there. Down 1.6, still not there. How many times do I have to go down 1.6? 4 times. So I multiply that by 4. How many total units do I need to move down then? 1.8. Lily, back to you. How many times do you have to move down 1.6? Or 4 times for a total of how many? Sorry.
Negative 6.4.
Down 6.4. Good. All right. What was our starting y coordinate? What was our starting y coordinate? 3, Stella?
6 or 5.
5. And I'm going to go down 6.4 units. So finally, where do I end up on the y-axis now? Where do I end up? If I'm at 5 right now and I go down 6.4, where do I end up on the y-axis? Tess, when you're ready.
Negative 1.4.
Negative 1.4, yeah. Okay, before, don't go on to the next one. 2 things. Number 1, is this point actually on my line? Over 1 and a little more, down 1 and a little more, right there, good. Does it look like it should be there? What was our ratio again? 4 to 1. So to the left should look much bigger than to the right if it's 4 to 1. So I'm pretty confident. Now let me go back. Let's say you totally forgot the negative sign, that you went down and you just did 8 divided by 5. This would become positive. This would end up being positive. And instead of subtracting, you would end up adding them and got 11.4. Everyone see the problem if I got 11.4? Way up there. You know you did something wrong. It didn't even fall on the darn line segment. And what you did wrong is probably forgot the negative. All right, you're on your own here. Let's see what you can do here at number 3. I'll give you a few minutes and then I'll write the final answer up on the board. 3 to 7 now. 3 to 7 the ratio. We always go by the first number in the ratio. Yep. Negative 0.2, 2.2 for that first one. Dividing everything by 10, then multiplying it by 3. And you'll notice that does end up on the line segment. That does end up on the line segment. And I see some of you guys starting the last one here. Last one, you can do it's 1-to-1, right? So you can do partitions. What's another way of doing this one though? You can do partitions. I'm just asking you to find the what though? Midpoint. So it doesn't bother me. You want to keep doing partitions like we did today, that's fine, to find the X and the Y, or you can bust out the midpoint formula. Right? It's the same point, 1-to-1 and midpoint. Same one. But make sure you get negative 0.2, 2.2 on number 3 before you move on. If not, let me know.